In this video, we're going to review a little bit of probability, things we've talked about already, and then start talking about conditional probabilities. So what you see here is a table about a certain college, and they've kind of divvied kids up by their GPA along the top and by their attendance on the side. And you can see that there were a total of 1,000 students that were part of this. Okay. What's the probability that a random student has a GPA between 2 and 3? So here that is, there are 475 out of the 1,000. So 475 divided by 1,000 is 0.475. What is the probability a student has a GPA under 2 and has skipped many classes? Okay, so GPA under 2 and skipped a lot of classes, so it's this cell right here. Out of the 1,000, so 80 divided by 1,000 is 0.08. What's the probability that a student has a GPA under 2 or has skipped many classes? Well, let's look up here. So GPA under 2 is right here. Skip many classes is here. So it's tempting to say, well, it's 110 plus 255. The problem, of course, is we've counted these 80 people twice. So I think what I would do, especially in a situation like this where we just have the table, is I might think that I would probably just add these 4 cells together to calculate how many people that includes. And if you add those up, it's 285 out of the 1,000, so 0.285. Suppose that the probability a construction company will be awarded a certain contract is 0.25, the probability it will be awarded a second contract is 0.21, and the probability they get both is 0.13. What's the probability they win at least one of the 2 contracts? Well, first, I did give the hint here of drawing a Venn diagram, and we certainly could do that like this, and then I'll talk about how we could have done this with the addition rule we learned about in the previous video. You could say, well, the probability they get both contracts is 0.13. So the probability they get the first contract is 0.25 total. That means that 0.12 goes in here. That's the probability they get that contract alone. And again, you look at this, the whole circle has to add up to 0.25. So for the other circle, the second contract, this is going to be 0.08. That's the probability they get that second contract alone because this total needs to be 0.21. So now you could just add these together and get 0.33 is your answer. Okay. Now the other way to do it is to use that modified addition rule that we learned about in the previous video, which says you can add the 2 together even though they aren't disjoint as long as you subtract that intersection off. And if you calculate that, you will definitely get 0.13. So I want to start talking about conditional probabilities, which is definitely one of the more useful types of probability problems in the real world. And I think you'll see that as we go, but I'll also explain some simple ways it's used. The conditional probability notation is this vertical line. This is read as the probability of A given B. So it's the probability that A happens given that B has occurred. And I always like to think about this visually in this way. If I know that B has happened, okay, so let me just do that. I know that B has occurred. I am inside this circle, okay? So nothing else is possible. Okay, we can just shade that out. Everything else outside of B can't happen. So now you say, well, what's the probability of A knowing that I have to be in that circle? Well, think about probability is always, you know, the what constitutes success or what we're looking for out of the total. So, you know, when you say, well, what's the probability I flip a coin or let's do roll a dice. Roll a die and get a 6. Well, there's 1 6 out of 6 possibilities, so it's 1/6. So when I say, well, what's the probability that A has happened, it's really just this sliver right here, this intersection point. So it's the probability of A and B, using the notation here, it's the probability of, and maybe I'm going to keep it out of there, the probability of A and B, remember the upside down U means and, out of the probability of B. And that is our formula for a conditional probability. The probability of A given B is the probability of A and B divided by the probability of B. And like I said, I always think about this as almost like a reframing of the possibility. You're saying, I know that I'm in B. This is now my whole sample space. Nothing else is true. So it's the probability of A and B occurring out of the whole sample space. Okay? So like I said, visually I think it makes sense with this Venn diagram. Now, it's a little bit of algebra you can do with this formula. You see this. This is something we're going to use in a coming problem, but obviously it's just multiplying both sides by the probability of B. You can see the adjustment of the formula. And as I said, we're going to use that in a future problem in a video coming up. Let's do a little bit of practice. So, at target field, the probability that a random fan buys a hot dog is 0.51. The probability they bought a soft drink was 0.23. And the probability they did both was 0.18. So, we could certainly fill out a quick Venn diagram here and say, well, this is 0.18. So probability of a soft drink alone is 0.05. The probability of a hot dog alone is 0.33, because that will give me those totals I want. Okay. Now, the probability, this first problem, the probability of a hot dog given a soft drink. Well, let's use the formula. The probability of a hot dog and a soft drink divided by the probability of a soft drink. Okay, so the probability of both was 0.18, and the probability of a soft drink was 0.23. So that would be my probability. That's going to be a high probability, right? Next, the probability of a soft drink given a hot dog. Okay, so by formula, it's going to be the probability of soft drink and hot dog divided by the probability of hot dog. So this is going to be 0.18 divided by 0.51. So not as large a value as the previous one. Here's why I bring that up. Sometimes people will look for, why would you use conditionals? This is a great example. Marketing. If you have a product that people often purchase after they purchased another product, maybe putting a discount on the first buy leads people to spend more money because they then make the second purchase. So what's the probability someone buys that second item? Given they bought the first, the higher that probability, the more likely we maybe offer a discount on the first in order to get people to buy the second item. Other uses of conditional probability, think about insurance rates. There's a reason that 18-year-old males pay more money in car insurance than 18-year-old females. The probability of an accident given that you are an 18-year-old male is much higher than the probability of an accident given that you are a 18-year-old female. All right? Finally, I just wanted to go back to our addition rule, soft drink or hot dog. We could certainly use our Venn diagram we made and just add them up. Or, remember, we could do the addition of the two, and then because they're not disjoint, subtract the intersection. Okay, in an upcoming video, I'm going to do more work with conditionals.